Now let us discuss about Hooke's law. So what do we understand by Hooke's law? Before coming to Hooke's law, we must have a clear concept about force. So what is force? Force is basically either a push or a pull is termed as force, right? So now coming back to Hooke's law. So what does a Hooke's law states? It states that if a mass is attached to a spring and the spring is either extended or it is compressed, then the spring will exert a force on the mass that is proportional to the distance which is travelled or moved from its natural position, right? So whenever we are going to attach some mass to this particular spring, suppose this is original spring and it is at equilibrium position in this particular point, this is the equilibrium position, that means it is the rest position. Now if we add some force at this particular part, at bottom of the spring we attached a force which is this, right? So we are going to add some mass or some object. Suppose we are adding a metal ball to this particular spring at this portion. So what will happen? It will suffer elongation. It will suffer a distance, right? So this was an equilibrium position and what happened is it moved to this particular portion or position. Clear? So this movement or this distance which is travelled by spring, right? So this spring is going to supply force which is equivalent to this particular x distance travelled, right? So how you can write the formula for applied force on this metal ball? How much force is exerted by a spring on this metal ball? So that is equals to, force is equals to, it is proportional to the distance travelled by the spring. So the distance travelled here is, this was equilibrium position and this is the new position after displacement, right? So x is the distance. If you will see here, x is the distance. So F is equal to x and minus k. What is k? K is nothing but it is our spring constant. What is spring constant here? Spring constant here defines the stiffness of spring. It measures the stiffness property of spring. Clear? So Hooke's law defines that if any mass is attached to the spring, then spring will exert a force equivalent to distance travelled by the spring. So this is equals to, F equals to minus k into x. K is our spring constant, right? And it is minus because it is going to travel some distance. In the same way, if you will attach two balls, so suppose 2x is the distance travelled. So what will be the force applied on these two balls? It will be equals to F equals to minus 2kx. Clear? Hooke's law is basically an example of an empirical law. Clear? Now moving ahead to the next, which is weight. So what is weight? Weight is basically a force on any object due to gravity. Any object which is experiencing some kind of force, that force due to gravity is termed as weight, right? There is a mass, there is a weight. Mass is a quantity, weight is a force. So weight is basically force experienced by any object due to gravitational force or due to Earth's gravity, right? If the object is near the surface of the Earth, then weight is given by W equals to M into G. M is the mass, G is force of gravity, and it is generally represented by 9.8 meter per second square of acceleration. Clear? So if you will see here, if an block of mass M is kept on the table, then it is M. But if we keep it free falling, then it will experience a mass of mg, which will fall downward the ground, right? The next one is normal force. So what do we mean by the word normal force? Normal force is what? If an object is resting on a table, then there are two forces acting on it. One is gravitational force, which is acting downward. As you can see here, if a book or a diary is kept on table, so there will be one force which will acting downward. It is termed as weight or gravitational force. Clear? And the another force which will be acting upward, which is equal to magnitude acting upward, right? So it is an equal and opposite forces which are acting on both the direction. Gravitational force will act downward, whereas normal force will act upward, right? So due to these two mutual forces, it will balance the system. Now suppose your object is kept in some inclined plane where there is some angle. So suppose this is our block which is kept on the inclined plane, and the inclination of this plane is theta, right? So for an object which is at some inclination, what will happen? So what will happen in that case? We need to resolve the components of this force. This Fn and this mg. See, mg, that is gravitational force, is always perpendicular. It is always vertical, right? So gravitational force will act on the downward direction. We need to resolve two different components. One will be mg cos theta and another will be mg sin theta. Clear? So F of n, that is the force which is normal force, will be encountered by mg cos theta, right? We need to apply this F of n equivalent to mg cos theta, then and then only this block will be at rest position. Suppose this F of n is greater than mg cos theta, or this F of n is less than mg cos theta, then the block position will be changed. Clear? Forces will always act perpendicular on the object. Remember that, right? So it will have to change. The next one is tension. The word tension, we all know the word tension, right? There is some stress. So what do we mean by the word tension? If a force is applied to both the end of rope, right, then we are saying that the rope is under tension. Why it is under tension? Because at both the end we are trying to apply force, and this tension is like other form of force. So tension is basically one kind of force which is applied from both the ends, right? So if you see here, there are two persons, they are holding single rope, but at the two different ends, and from both the ends what they are trying is, they are trying to apply pressure or force on their own direction. The tension is basically a force which is equal and opposite in directions, right? Equal and opposite in direction, then it is termed as tension. Now coming next to characteristics of forces. So what are various characteristics of forces, right? We must understand the force and its characteristics. So what are various characteristics of forces? The first and foremost important characteristic of force is it is a product of interaction between two objects. Always remember, force is basically interaction between two objects. Two objects has to be there to interact with each other to define force. Clear? So first characteristic of force is it is a product of interaction between two different objects. The second point is, as you can see here, it may change the state of motion. That means if the object is at rest position, due to force, object may start to run, right? If it is at rest position, it may go to unsteady state, right, or dynamic state of motion. For an example, an object in motion may speed up or slow down once the force acts on it. Suppose there is some moving body, and if you apply force on the direction of motion, the speed of movement will be faster. And suppose there is a moving body and you are applying force opposite to the direction of motion, then speed of that body will be reduced. So a force is responsible to change the state of motion. Third one is it can also alter the direction of moving object, right? This is very true. If you are applying force which is greater than the motion of that particular object, it can divert its direction. For an example, if we take, let's take a satellite orbiting around Earth. It can change direction regularly due to attraction of gravity from our planet, right? The orbits of satellite keep on changing due to different gravitational forces. Clear? Next one is it may change the shape of an object, or it may change the shape of object. So how a force can change shape of any given object? For an instant, let us take a solid object. So a solid object may become smaller when force is applied to it. If you will apply a force and if there is intermolecular distance which is present, it may get compressed due to force. Clear? Next one is force is a vector quantity. Please remember that a force is a vector quantity. What do we mean by a vector quantity? Vector quantity means it has magnitude and it has direction, correct? So a force have both of them. Force have a magnitude, force have direction. That's why we call it as a vector quantity. And the last and foremost important characteristic of force is it can be added or grouped, resulting in a net or resultant force. You can apply different amount of forces, or you can combine them and apply equivalent amount of force together. Clear? So this is a basic important characteristics of forces. So let's just have a quick recap of what we have studied today. That is, what are different characteristics of forces, what do we mean by weight, what do we mean by tension, and what is Hooke's law. Hooke's law basically deals with force applied by spring to the object, right? So it is F equals to minus K into X. X is the distance traveled by the spring from its equilibrium position. Clear? And K is our spring constant, which is a measurement of stiffness of our spring. Then coming to weight, what is weight? Force occurred on any object due to gravitational force is termed as weight, right? So force acting on any object, any mass due to gravity of earth is termed as weight. What is tension? Tension is a force which is exerted on both the ends of any object and it is equal and opposite in direction. Then we have seen characteristics of force. So there are various characteristics of force which we have seen, right? Just like that, force is a product which is acting between two different objects. Force has potential to change motion of any object. Force has potential to change direction of moving objects. Force has potential to change shape of any objects, right? Most important is force is a vector quantity. That means it has a magnitude and it has a direction. And the last one is force can be added or grouped into equivalent resultant force. Clear? I just hope all the topic associated with force and Hooke's law which we have covered today is quite clear. Thank you.